The universe began 8 billion years ago, at least that's what we've been told. A single moment, a blinding flash of creation, from which time, matter, and space were born. But what if that story isn't the whole truth? For decades, scientists believed the Big Bang was the beginning of everything. Yet when they looked closer, the math broke down. The laws of physics, the very fabric of reality, began to collapse. Something was missing, and now new evidence is emerging, proof that before the hot, violent birth of our universe there was something else. Something older, something colder, something that existed before time itself. What came before the beginning? The answer could change everything we know about existence, about the cosmos, and about ourselves. If you crave the mysteries of the universe, if you live for the truth that lies beyond the stars, then don't just watch, be part of the journey. Subscribe now, and together, we'll uncover the secrets of creation itself. For nearly a century, the Big Bang Theory has stood as the defining explanation for how our universe began. It told us that everything space, time, energy, and matter burst into existence from a single, incomprehensibly dense point about 8 billion years ago. From that moment, the universe began to expand, cool, and evolve into the vast cosmic tapestry we see today. Galaxies formed, stars ignited, worlds took shape, life emerged, and somewhere along that endless chain of cosmic events, we appeared, tiny observers staring back at the infinite, wondering how it all began. But now, scientists are beginning to question the very foundation of that story. What if the Big Bang wasn't the beginning of everything? What if it was just a chapter in an even larger cosmic cycle, one that stretches beyond time itself? To understand why this question even exists, we must first look at what the Big Bang Theory really means. Contrary to popular imagination, the Big Bang was not an explosion that happened somewhere in space. There was no center that burst outward into emptiness. Instead, the Big Bang was an expansion of space itself. Every point in the universe expanded simultaneously. Space itself began stretching, carrying galaxies with it, like raisins inside a loaf of rising bread. But if space and time were expanding, then what existed before they began? If time itself had a starting point, what came before it? For decades, scientists avoided this question because, according to Einstein's equations, the beginning of the universe was a singularity, a point of infinite density and zero volume where the known laws of physics completely break down. A singularity isn't something we can imagine or describe. It's a mathematical dead end, a place where all the equations that govern matter and energy simply stop working. It's as if the universe hides its own origin behind a curtain of mathematical impossibility. For most of the 20th century, cosmologists accepted that the Big Bang marked the beginning of both space and time. There was no before, because before simply didn't exist. But over the years, as our understanding of quantum mechanics and relativity deepened, cracks began to appear in this once settled picture. In the strange world of quantum physics, nothing is ever truly empty. Even in the complete absence of matter, a mysterious ocean of energy churns beneath reality. Tiny fluctuations constantly appear and vanish, a restless quantum foam that never stops moving. According to this view, even nothingness is alive with potential. And that led scientists to an extraordinary idea. What if the universe didn't come from nothing, but from something? What if the Big Bang was not the birth of existence itself, but a transformation, a sudden phase change in an eternal, quantum reality that has always been? This idea changes everything. If the Big Bang wasn't the first moment of creation, then the story of our universe is not one of birth from absolute nothingness. It's the story of transformation, of cycles, of continuity. Perhaps the universe we inhabit today emerged from the remnants of a universe that came before, a cosmos that lived, expanded, aged, and eventually collapsed under its own gravity, giving birth to ours in an endless cosmic rhythm. This concept, known as the Big Bounce, is one of several models that suggest the universe has no true beginning or end, but oscillates through cycles of birth, death, and rebirth. In these models, the singularity of the Big Bang is replaced by a transition point, a bounce where contraction turns into expansion. In that brief, incomprehensibly small instant, everything we now see was once compressed into an unimaginably hot and dense state, but not infinite. Instead of breaking physics, this model suggests that quantum gravity, an as yet unified description of how gravity behaves on quantum scales, could prevent the universe from collapsing entirely, causing it instead to rebound. In other words, the universe might breathe. It expands, contracts, and expands again eternally. But that's just one possible story. Other scientists have proposed that our universe might be part of a much larger structure, a multiverse, a cosmic landscape of infinite universes, each bubbling into existence with its own Big Bang. In this view, our Big Bang was just one of many. New universes could be born constantly, emerging from the quantum foam like sparks from a cosmic fire. The question of what came before the Big Bang, then, becomes a question of what gave rise to our universe's bubble in this infinite sea of creation. Perhaps another universe collided with ours, triggering the expansion we see today. Or perhaps our universe simply tunneled into existence from a previous vacuum state, a quantum fluctuation in a timeless field that has no beginning or end. One of the most striking pieces of evidence driving this shift in thinking comes from the cosmic microwave background, the oldest light in the universe. This faint afterglow, first discovered in 1965, is the leftover radiation from the Big Bang, stretched and cooled over billions of years. When scientists look closely at this light, they see tiny temperature fluctuations, minute variations that seeded the formation of galaxies. But recently, researchers have begun to notice strange, unexplained patterns in that ancient radiation. These anomalies don't fit perfectly with the predictions of the standard Big Bang model. Some cosmologists, including Nobel Prize-winning physicist Roger Penrose, suggest that these patterns could be scars, left over from a previous universe, a cosmic memory, faint but enduring, written into the background of our own. If Penrose's theory, known as conformal cyclic cosmology, is correct, then universes may succeed each other endlessly. Each one expands, cools, and fades into darkness until all matter decays and only radiation remains. At that point, the universe becomes so empty and uniform that it's indistinguishable from the conditions of the Big Bang, and the cycle begins anew. In this view, the Big Bang was not the beginning, but the latest rebirth in an infinite procession of cosmic epochs. These ideas are bold, even controversial. They challenge our most basic intuitions about beginnings and endings. But they arise from a deeper realization that the universe and the laws that govern it are not bound by human notions of time and causality. When we ask what came before the Big Bang, we are projecting the logic of time backward into a region where time itself may not exist. Time, according to relativity, is not a universal constant. It's a property of the universe, woven together with space into a single fabric. If that fabric began at the Big Bang, then asking what came before is like asking what lies north of the North Pole. The question dissolves, not because it's meaningless, but because it belongs to a different order of reality. Still, the human mind cannot resist wondering. We are creatures of beginnings. Every story we tell has one. We search for causes, for origins, for first moments. It's in our nature to believe that everything must have come from something. And maybe that instinct is not entirely wrong. Maybe, in some deeper, pretemporal sense, there was always something. Maybe the cosmos has no absolute beginning because existence itself is fundamental, eternal, and ever-changing. The Big Bang, then, is simply one visible manifestation of a process that has no start or end, an endless unfolding of energy and form. Recent advances in quantum cosmology are bringing us closer to describing that process mathematically. Using theories like loop quantum gravity, researchers are exploring what happens when Einstein's general relativity is merged with quantum mechanics. In this framework, space is not a smooth, continuous fabric, but a granular structure composed of tiny, discrete loops. As the universe contracts, these loops resist compression, creating a repulsive force that prevents a total collapse. The result, instead of an infinite singularity, the universe bounces back. The Big Bang in this model was a rebound, not a beginning. There was a universe before ours, and there may be another after it. If these ideas are true, they don't just reshape cosmology, they reshape our sense of identity. It means that everything that exists today, every star, every planet, every atom in your body, is part of a cosmic continuum stretching across eons. Matter and energy don't simply vanish, they transform, reconfigure, and emerge anew in each cycle. The carbon in your blood, the iron in your veins, the oxygen you breathe, these were all forged in stars that lived and died billions of years ago. Those stars themselves may have been born from the ashes of even older universes. You are not separate from the Big Bang. You are its living memory. The notion that the Big Bang was not the absolute beginning opens a profound doorway, one that connects science with something deeply philosophical. It suggests that the universe is not a one-time miracle, but an eternal process of creation. It invites us to imagine existence not as a line with a starting point, but as a circle endlessly turning. It reminds us that every ending may simply be another beginning in disguise. And perhaps that's the ultimate revelation, that the Big Bang was not the start of everything, but merely the latest spark in an eternal cosmic fire. That what we call the beginning is just one beat in the infinite rhythm of existence. And that beyond the limits of our equations, beyond the boundaries of our telescopes, lies a truth so vast and timeless that it transcends the very concept of beginnings and ends. The universe did not emerge from nothing. It has always been becoming. The idea that our universe may have experienced a big bounce is one of the most profound and mind-bending possibilities ever proposed in cosmology. For nearly a century, we've been told that the Big Bang was the beginning, the singular moment when time and space themselves erupted into existence from a point of infinite density. But what if that story is incomplete? What if the Big Bang wasn't the start of everything, but rather the continuation of something eternal, the latest heartbeat in an infinite cosmic rhythm? What if before our universe expanded it collapsed? What if there was another universe before ours, one that lived, aged, and finally fell back in on itself, only to give birth again to us? To understand this possibility, we must first confront the problem that has haunted cosmology since its earliest days, the singularity. When scientists use Einstein's theory of general relativity to run the clock backward, to trace the universe's expansion to its origin, the equations eventually break. They reach a point where the density of matter becomes infinite, and space and time themselves shrink to zero. This singularity isn't a real object. It's a sign that our physics fails to describe what happens at extreme scales. In the simplest sense, the singularity is a wall, a limit. It's the place where our understanding of reality simply stops. But physicists have long suspected that nature does not deal in infinities. Infinity to them is not a physical truth, but a mathematical warning, a signal that the tools we're using are incomplete. And so, a new generation of scientists began to ask, what if there was no singularity at all? What if, instead of an absolute beginning, the universe underwent a bounce, a moment when contraction turned into expansion? The Big Bounce hypothesis proposes exactly that. According to this view, our universe wasn't born from nothing. It was born from a previous universe that had been expanding for eons before eventually slowing down, reversing, and collapsing under its own gravity. As it compressed, matter and energy became hotter and denser, until quantum effects, the strange, jittery laws that govern the subatomic world, took over. At that moment, the universe reached a minimum size, not zero, and then rebounded outward in a new expansion. The Big Bang in this vision was not the birth of the universe, but its rebirth. To see how this might work, imagine the universe as a cosmic spring. You compress it more and more, and just when it seems it will snap, it pushes back with unimaginable force, unleashing another expansion. That is the essence of the Big Bounce. Instead of a beginning and an end, the universe oscillates through cycles, expanding, contracting, and expanding again, forever. The seeds of this idea were planted long ago, even before the term Big Bang existed. In the early 20th century, some physicists speculated that the universe might not be static or linear, but cyclical. One of them was the great theoretical physicist Richard Tolman, who proposed in the 1930s that a closed universe, one with enough mass to halt its expansion, could eventually collapse and then explode again. He imagined an endless series of bangs and crunches, with each cycle erasing the memory of the one before. For decades, the idea faded into obscurity, as observations suggested the universe would expand forever. But in the 21st century, new discoveries have revived it. Quantum physics tells us that at extremely small scales, gravity behaves differently than Einstein's equations predict. Space and time themselves may not be smooth continua, but composed of discrete, indivisible units, a kind of quantum fabric that resists infinite compression. This concept is at the heart of loop quantum gravity, a theory developed by physicists like Carlo Rovelli and Abhay Ashtekar. In this model, when the universe collapses to a critical density, the quantum structure of space generates a powerful repulsive force. It's like a spring that can never be fully squeezed. No matter how much pressure builds up, it will always push back. That pushback, according to the equations, causes the universe to rebound, to bounce, instead of collapsing into a singularity. In this sense, the Big Bang becomes not a creation event, but a transition, the moment the previous universe collapsed and our own began to expand. The collapse phase, sometimes called the Big Crunch, may have lasted for trillions of years, as galaxies drew together and the fabric of space contracted. And then, at the smallest possible scale, that contraction reversed. What emerged was a new cosmos, with its own space, time, and matter, expanding in all directions. Everything that exists today, stars, galaxies, planets, and life, may be the echo of a universe that came before. But this raises haunting questions. If a universe collapsed and gave birth to ours, what was that universe like? Would its physical laws have been the same? Would it have contained galaxies like ours, stars like ours, people like us? Or would it have been utterly different, a universe of unfamiliar forces and structures? The answers may be written in the oldest light of all, the cosmic microwave background. Some researchers believe that tiny anomalies in that radiation, strange circular patterns, or subtle asymmetries, could be the fingerprints of a previous cosmic cycle. If so, then the universe remembers. Buried in the afterglow of the Big Bang may lie the whispers of a universe that existed before ours. Roger Penrose, one of the most brilliant physicists of our time, takes this even further. In his model of conformal cyclic cosmology, he proposes that the universe doesn't bounce in the traditional sense, it simply fades and restarts. As the universe expands over trillions of years, all matter decays, black holes evaporate, stars die. Eventually, only radiation remains, and in a strange twist of physics, a universe filled with only massless particles becomes indistinguishable from the ultra-hot, ultra-dense state at the Big Bang. At that point, a new cosmic cycle begins, seamlessly connecting one eon to the next. To Penrose, our Big Bang is not unique. It is the latest in an infinite chain of cosmic rebirths. This idea is both staggering and humbling. It suggests that existence itself is cyclical, that the cosmos may never have had a true beginning and will never have a final end. In this view, entropy, the measure of disorder that increases over time, doesn't spell the death of the universe, but its renewal. What seems like decay on one scale becomes creation on another. Each dying universe sets the stage for the birth of the next. Other versions of the Big Bounce take a more quantum, mechanical approach. In some models, the universe tunnels through the barrier between contraction and expansion, much like a particle passing through a wall in quantum mechanics. In others, the bounce occurs through a phase transition, a shift in the fundamental state of space, time itself. These theories are still being tested, refined, and debated, but they share a common vision that the cosmos is resilient. It never truly collapses into nothingness, it transforms. If we accept this idea, it changes how we see everything, not just physics, but our place in the universe. Because if the Big Bounce is real, then everything that exists today, every galaxy, every atom, every heartbeat, is part of an endless chain of creation and destruction. You are not living in the universe's first dawn. You are part of a story that has unfolded countless times before. The atoms in your body may have been forged not only in the hearts of stars, but in the very fabric of universes long vanished. You are, in a very real sense, made of ancient memory, the residue of previous cosmoses that lived, died, and were reborn. And yet, the Big Bounce carries with it a quiet beauty, the beauty of renewal. It suggests that even the universe itself cannot escape the cycle of death and rebirth. It too must collapse to be reborn, must end to begin again. That is the rhythm of existence, echoed everywhere from the smallest cells to the grandest galaxies. Stars explode and scatter their ashes across the cosmos, only for new stars to form from their remains. Galaxies merge and reform, life dies and gives birth to new life. The universe mirrors itself on every scale. One might ask, if the universe bounces eternally, does it ever change? Are all cycles identical, or does each one evolve, becoming slightly different than the last? That question touches the heart of cosmic evolution. Some theorists suggest that the conditions of each bounce, the distribution of energy, the balance of forces may shift slightly, leading to universes with different physical constants each time. Over countless cycles, universes could become more complex, more structured, perhaps even more capable of producing life. In this sense, cosmic evolution may parallel biological evolution, a universe learning to know itself through repetition. Others wonder what happens to information across bounces. Does the memory of one universe carry into the next? Quantum mechanics tells us that information cannot be destroyed, even when matter is transformed. Could it be that some echo of the previous universe survives, embedded in the quantum fields that gave birth to ours? Perhaps that is what we see in the strange imprints of the cosmic background radiation, the faint scars of an earlier existence written into the fabric of our reality. Of course, these ideas remain speculative. We have yet to observe a bounce directly, and the evidence is subtle, hidden behind the veil of 8 billion years. Yet, the very fact that such ideas can be expressed mathematically, that they emerge naturally from attempts to reconcile quantum mechanics with gravity, gives them weight. They offer a way to remove the singularity, to replace something from nothing with a continuous, self-renewing universe. And that is no small thing, but beyond the equations lies something deeper, something profoundly human. The Big Bounce gives us a vision of the universe that mirrors our own experience of life and death. Everything we know follows cycles, day and night, birth and decay, loss and renewal. Why should the universe itself be any different? Perhaps creation and destruction are not opposites but partners, each giving meaning to the other. Perhaps even the cosmos must die to know itself again. The Big Bounce invites us to see existence not as a fragile accident, but as an indestructible process. It tells us that endings are illusions, that what we call the end of the universe is merely the beginning of another. It whispers that nothing is ever truly lost, that every collapse contains the seed of rebirth. If that's true, then even our own existence, fleeting, fragile, and small as it may seem, is part of something eternal. Maybe, in some unimaginable future, when our universe has expanded to cold emptiness, it too will begin to contract again. Galaxies will drift closer, stars will collapse, the night sky will fill not with light, but with the memory of what once was. And then, in a final crescendo of compression, everything will return to that dense, hot state, not to vanish, but to bounce once more, igniting another cosmic dawn. A new universe will rise from the ashes of the old, filled with new stars, new worlds, new eyes to look up and wonder. And when that moment comes, perhaps somewhere, somehow, the echoes of us, our atoms, our thoughts, our curiosity will still be there, woven into the quantum fabric of the next beginning. Because in the grand rhythm of existence, nothing truly ends, it only transforms. The universe, like a heartbeat, contracts and expands forever. When we gaze into the night sky, we are not just looking at stars and galaxies. We are looking back in time. Every beam of light that reaches us from deep space carries a story, a memory of how the universe once was. The further we look, the older the light becomes, until eventually we reach the edge of what we can see, the faint, almost invisible glow that fills all of space, the oldest light in the cosmos. This light is known as the cosmic microwave background, or CMB, and it is one of the most profound discoveries in the history of science. It is the afterglow of the Big Bang itself, the faint whisper of creation, still echoing through the universe nearly 14 billion years later. But as scientists have studied it in greater and greater detail, something strange has emerged. Hidden within this ancient light are clues, subtle, almost imperceptible patterns that might reveal the existence of something that came before the Big Bang. These clues could be evidence that our universe is not the first, that our cosmos carries within it the memory of a universe that lived and died long before ours began. The story of the cosmic microwave background begins about 380 years after the Big Bang. Before that time, the universe was a blinding fog of hot plasma, a dense soup of particles and radiation. Photons, the particles of light, were constantly scattering off electrons, unable to travel far before being deflected. Space itself was opaque, like the inside of a star, but as the universe expanded, it cooled. Eventually, it reached a temperature at which electrons and protons could combine to form neutral hydrogen atoms. When that happened, light could finally travel freely through space. Those first free photons have been traveling ever since, stretching and cooling as the universe expands. Today, nearly 14 billion years later, that ancient light has been stretched into the microwave part of the spectrum, and it fills the entire sky uniformly. No matter where you point a radio telescope, you will detect it, the soft glow of the universe's first light. When scientists first detected this radiation in 1965, quite by accident, it provided irrefutable proof of the Big Bang theory. It showed that the universe really did have a hot, dense beginning. But over time, as instruments improved, scientists began to see that this light was not perfectly uniform. There were tiny fluctuations, minute temperature differences of only a few millionths of a degree. These ripples, imprinted on the CMB, were like fossilized sound waves from the early universe, the seeds that would eventually grow into galaxies and clusters of galaxies. They told us that even in its infancy, the universe was not perfectly smooth. There were slight variations in density that gravity would later amplify into the structures we see today. For decades, cosmologists studied these fluctuations to understand how the universe evolved. Satellites like COBE, WMAP, and Planck mapped the cosmic microwave background in extraordinary detail, turning the sky into a vast cosmic fingerprint. From those maps, scientists could measure the universe's age, its composition, and its shape with incredible precision. But amid all that data, something else began to emerge: small anomalies, odd patterns that didn't quite fit with the predictions of the standard model of cosmology. These anomalies hinted at something deeper, something that could reach beyond the Big Bang itself. One of the most intriguing discoveries came from the work of Nobel Prize-winning physicist Roger Penrose. Penrose, a pioneer in the study of black holes and relativity, proposed a radical idea called conformal cyclic cosmology, or CCC. In this model, the universe doesn't begin and end, it moves through infinite cycles, or eons. Each eon expands, ages, and fades away, and when all its matter and energy have dispersed, it becomes the seed for the next. According to Penrose, the end of one universe and the beginning of the next are not separated by a singularity or a bounce, but by a strange kind of transformation. As the previous universe expands and cools, all matter decays, black holes evaporate through Hawking radiation. Eventually, only light, pure radiation remains, and at that point, when all mass is gone, time and distance lose their meaning. The universe becomes scale, invariant, meaning it looks the same at all scales, just like the ultra-hot, dense state at the Big Bang. One eon flows seamlessly into another. If this is true, then traces of the previous eon might still be visible in the cosmic microwave background of our current universe. Penrose and his collaborators claim to have found such traces, faint circular patterns in the CMB, that could be the remnants of supermassive black holes from the universe before ours. When black holes evaporate, they release enormous amounts of energy, and in Penrose's theory, this energy can leave an imprint that carries over into the next eon. These so-called Hawking points, named after Stephen Hawking, who predicted black hole evaporation, might be the fingerprints of a cosmic past older than time itself. If these circles truly exist, they would be one of the most extraordinary discoveries in history, direct evidence that our universe is not unique, but one in an endless series of cosmic cycles. The idea that the CMB might contain such information is both poetic and profound. It means that the universe remembers. That somewhere in that faint microwave glow, the light we detect today carries the memory of events that happened before our universe was even born. But Penrose's idea is not the only one suggesting that the CMB could reveal what came before the Big Bang. Other cosmologists have proposed that fluctuations in the CMB could be the result of collisions between our universe and others. In some models of the multiverse, particularly those arising from string theory, universes form as bubbles in an endless cosmic foam. Each bubble expands with its own Big Bang, growing and evolving independently. Occasionally, two bubbles may collide, and that collision could leave a mark, a circular scar in the cosmic microwave background. Scientists have searched for these signatures in the CMB data, and while none have yet been confirmed beyond doubt, the possibility remains tantalizing. It suggests that our universe could be one of many, part of a vast multiverse that constantly births new realities. There are other anomalies too, mysterious cold spots, strange alignments, and asymmetries in the CMB that defy easy explanation. The most famous of these is known as the CMB cold spot, a large region of the sky that appears unusually cool compared to its surroundings. Some scientists argue that it's just a statistical fluke, or perhaps caused by a massive void, an underdense region of space that affects how light travels through it. But others speculate that it could be something more, perhaps the remnant of a cosmic collision, or even evidence of a pre-Big Bang structure imprinted onto our universe's fabric. If that's true, then this cold spot could be a window into a realm beyond our own cosmic horizon. As our instruments grow more sensitive, the details hidden within the CMB become sharper. The Planck satellite, launched by the European Space Agency, has provided the most precise map yet of this ancient light. Its data have allowed scientists to test competing cosmological models with unprecedented accuracy. Yet even with all this precision, the mystery deepens. The CMB tells us almost everything about what happened after the Big Bang, how matter clumped, how the universe cooled, how it evolved. But it also hints, quietly, at something before, something written between the patterns, in the slight deviations from perfection that refuse to fit our equations. One of the most haunting aspects of the CMB is its universality. No matter where we look, it's the same. It envelops us completely, a cosmic memory surrounding all of existence. When you tune an old television set between channels, a small fraction of the static you see is actually this ancient radiation. That noise, that soft, random hiss, is the echo of creation itself. Every single human being who has ever lived has been bathed in that light. Every mountain, every ocean, every leaf and atom, all have been illuminated by the same ancient photons that began their journey long before the Earth even existed. In a very real sense, we are all living inside the afterglow of the beginning, but perhaps it's not the beginning after all. Perhaps it's just the most recent spark in an eternal fire. If the CMB does hold evidence of a universe before ours, then our entire understanding of cosmology must shift. It would mean that time did not begin with the Big Bang, it merely restarted. It would mean that the universe has a kind of continuity, that even as it dies, it carries forward the imprint of its previous state. It would mean that creation and destruction are part of a single, unbroken cycle, that no energy, no information, no memory is ever truly lost. And if information from a past universe can be found in the CMB, then perhaps that information, that memory, could one day be decoded, allowing us to glimpse a universe that existed before ours. Some scientists believe that quantum entanglement might play a role in this cosmic memory. In quantum theory, particles can remain connected across vast distances, their states intertwined even when separated by billions of light years. If such entanglement existed across a bounce or transition from one universe to another, it could preserve a thread of continuity, a link between worlds. The CMB could then be the faint signal of that thread, the remnant of an entangled state that stretches beyond the limits of time. Yet, as thrilling as these ideas are, they also remind us how little we truly know. The universe is vast beyond imagination, and our understanding is still in its infancy. For every mystery we solve, new ones arise, but perhaps that's the beauty of it. The CMB is not just a relic of the past, it's a reminder of how much remains to be discovered. Every photon that reaches our telescopes has been traveling for nearly 14 billion years, crossing the entire history of existence to whisper its story to us. And within those whispers may lie the secrets of universes that came before and universes yet to come. The thought that light can carry memory, that photons born in one universe could illuminate another, is almost spiritual. It suggests that the cosmos itself has consciousness of its own past, that it never truly forgets, that the story of existence is written not in stone, but in light. And that light still shines everywhere, all around us, if only we learn how to read it. So the next time you look up at the night sky, remember, the darkness you see is not empty. It is filled with light too faint for the eye to perceive, light that has been traveling for nearly the entire age of the universe. That light is a message, an ancient record, older than stars, older than galaxies, perhaps older even than time. In its faint glow may lie the answer to the greatest question of all: what came before the beginning? Perhaps the truth is that the universe never truly began and never truly ends. It merely changes form, carrying its memories forward in waves of light that fill the void. The cosmic microwave background is that memory, the oldest, purest, most enduring message ever written. And we, the beings capable of reading it, are part of its unfolding story. We are the consciousness through which the universe remembers itself. Every discovery we make brings us one step closer to understanding not just where we came from, but what existed before there was even a where. And maybe that's the ultimate revelation hidden within that ancient light, that the universe, in all its vastness, is not a random event, but a continuum of existence, eternal and self-aware, always, leaving traces of what it once was in what it will become. The cosmic microwave background is not just a relic of the Big Bang. It is the echo of eternity, time, the quiet, relentless current that carries every atom, every star, and every heartbeat forward. It's something we feel but cannot touch, something that defines our existence yet remains invisible. Every moment of our lives is chained to it. We move through it like swimmers in a river, never able to pause or go back. But when scientists began to peer into the origins of the universe, they found something extraordinary. Time itself may not have always been here. According to the evidence gathered from cosmology, relativity, and quantum physics, time, the very flow of before and after, began at the Big Bang. Before that moment, there was no ticking clock, no past, no future, not even a before, for the Big Bang to emerge from. The event that created space and matter also created the stage on which all events unfold, time itself. This is one of the most profound concepts in all of science, that time is not an eternal background, not a boundless canvas stretched forever in both directions. It has an edge, a boundary, a beginning, and that boundary is the Big Bang. Yet as soon as this idea was born, it sparked a question so deep it still haunts the minds of physicists and philosophers. If time began at the Big Bang, what does it mean to ask what came before it? To understand why time might have begun at the Big Bang, we need to go back to Einstein. Before his work, scientists thought of time and space as separate things, an unchanging stage where the drama of the universe played out. But Einstein showed that space and time are woven together into a single entity, space-time. Massive objects warp this fabric, causing what we perceive as gravity. Space tells matter how to move, and matter tells space how to curve. But in Einstein's equations, space-time itself is not static. It can expand, contract, and even originate. When scientists applied his theory to the cosmos as a whole, they found something shocking. The equations predicted that space must be expanding. And if space is expanding today, it must have been smaller in the past. If you reverse the clock, tracing that expansion backward, everything, galaxies, stars, atoms, contracts to an unimaginable density and heat. Eventually, you reach a point where the equations break down entirely. That point is what we call the singularity, the beginning of space and time. In the singularity, our understanding of physics collapses. It's not just that the density becomes infinite, it's that time itself ceases to have meaning. There is no before, because before requires time, and time didn't exist yet. Asking what came before the Big Bang is like asking what's north of the North Pole. The question itself dissolves. The Big Bang wasn't an explosion in space, it was the explosion of space. It was the moment when time and space came into being together, expanding from a state that defies our comprehension. This realization changes everything about how we understand reality. It means the universe doesn't simply exist in time, it creates time as it exists. Time is not an eternal river flowing through a pre-existing landscape. It's more like the wake behind a boat. It comes into being only as the universe moves forward. From this perspective, time is not fundamental but emergent. It arises from the unfolding of the cosmos itself. But even with this profound insight, the mystery deepens. If time began at the Big Bang, why does it move forward? Why can we remember the past but not the future? The answer may lie in the second law of thermodynamics, the law of entropy. In simple terms, entropy measures disorder. The second law states that in any closed system, entropy always increases over time. That means the universe moves from order to disorder, from simplicity to complexity. At the Big Bang, the universe was in an incredibly low entropy state, perfectly ordered, smooth, and uniform. As it expanded, that order began to unravel, galaxies formed, stars ignited, life emerged, all as part of the grand process of entropy increasing. Time, it seems, is the direction in which entropy grows. This idea suggests that the arrow of time, the reason we experience moments as moving forward, was set in motion by the Big Bang itself. Time flows because the universe began in a state of astonishing order, and everything since has been a gradual slide toward chaos. Every heartbeat, every sunrise, every thought in our minds is a ripple on that current of entropy. But then comes the most astonishing question of all. Why was the universe so ordered at the beginning? Why did it start in such an improbable, low-entropy state that remains one of the greatest unsolved mysteries in physics? Some theorists suggest it's a clue that the Big Bang might not have been the ultimate beginning after all. Perhaps our universe inherited its order from a prior state, a pre-existing structure that somehow gave rise to ours. Stephen Hawking wrestled with this question for decades. Along with James Hartle, he proposed a bold idea known as the no-boundary proposal. According to this model, the universe didn't emerge from a singular point at all. It has no boundary in time. In the same way that the surface of the Earth has no edge, you can travel around the globe without ever falling off. The universe's beginning might not be a sharp moment, but a smooth curve. In this picture, time gradually emerges from a timeless state, like the dawn blending softly into day rather than a light switch flicking on. Before time as we know it existed, there was a kind of quantum foam, a realm where space and time fluctuated and blurred together. Out of that timeless quantum sea, the universe rolled into existence. In this sense, asking what came before the Big Bang might be meaningless because there was no before. Time as a concept only applies after the Big Bang. The universe didn't come from something in time. Time came from the universe. Hawking famously said, "The question of what happened before the Big Bang is meaningless, because there was no time before the Big Bang for anything to happen in." That's not just poetic, it's mathematically consistent with quantum cosmology. But even as science grapples with this idea, new theories continue to challenge it. Some cosmologists believe that time could be cyclical, that after the universe expands and cools, it may one day collapse and ignite a new Big Bang, creating a loop of time without a true beginning or end. In such models, time might not have a starting point, but rather an eternal rhythm, expanding, contracting, rebirthing itself endlessly. In others, time could be an illusion, a construct that emerges from deeper physical laws. In certain interpretations of quantum mechanics, the fundamental equations are timeless. Time doesn't exist at the deepest level of reality. It's something that arises only when we look at large systems, like the universe itself. So, what does it mean if time began at the Big Bang? It means that the universe isn't moving through time, it's creating it, moment by moment. Each second is born as the cosmos expands, each instant carved out of the fabric of existence. It also means that our experience of time, our memories, our sense of progression is intimately tied to the universe's evolution. We are not outside of time, observing it, we are part of it. We are beings made of time, our very consciousness unfolding in sync with the universe's expansion. It also reveals something deeply humbling. If time had a beginning, then everything that has ever existed, every star, every galaxy, every love, every thought, has arisen within that finite window. Our entire cosmic story is contained within the lifespan of time itself. But perhaps most beautifully, it means that we, as conscious beings, are one of the universe's ways of witnessing its own creation. We are fragments of time aware of time, tiny sparks of awareness that look back across 8 billion years and ask, how did it all begin? Even our ability to ask that question is a miracle born from time's unfolding. Somewhere in the early universe, clouds of hydrogen collapsed into stars. Those stars forged heavier elements, and from those elements came planets and life. And from that life came us beings who can reflect upon time itself. In a sense, we are the universe becoming aware of its own timeline. But despite how much we've learned, time remains elusive. We can measure it, divide it, predict its passage, but we cannot truly grasp what it is. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." From a relativistic standpoint, all moments in time coexist, the past has not vanished, and the future already exists. To a being outside of time, the universe might appear as a vast frozen structure, where every event, from the first flash of the Big Bang to the last fading star, exists simultaneously. What we perceive as the flow of time may simply be our consciousness moving along that structure, like a beam of light scanning through a film reel. If that's true, then time is not a river flowing forward. It's a dimension, and we are travelers within it. The Big Bang was not just the creation of space, but the creation of this entire structure, the whole of past, present, and future all at once. From that perspective, time did not begin, and then continue. It simply exists as part of the universe's total geometry. We experience it sequentially because our minds are built to perceive change, but in reality, every moment might be eternal, written into the fabric of spacetime forever. This view leads to a profound realization. If time began at the Big Bang, then everything that has ever been or will be is part of that same cosmic creation. The birth of the first star and the death of the last are both contained within that single act of creation, a universe expressing itself across billions of years, yet existing as one eternal whole. From the outside, there may be no beginning or end, just existence, timeless and complete. Still, there's something awe-inspiring about imagining that moment when time first began. Imagine the silence before silence, when there was no before. Imagine the instant when the first second ever ticked, not in a place, not in space, but everywhere at once. A universe igniting from nothing, time unfurling like a newborn fabric, stretching, vibrating, coming alive. That first moment was not just the start of the cosmos. It was the beginning of every heartbeat that would ever exist, every sunrise, every story, every life. The birth of time was the birth of meaning itself. And so, when scientists say that time began at the Big Bang, they're not merely describing a physical event. They're describing the emergence of existence as we know it. It means that reality is not built upon timeless laws alone, but upon the very act of becoming. It means that the universe, and everything within it, is a story unfolding, not an object existing. It means that we, too, are part of that story, fleeting, but real, temporary, but luminous. Maybe in the end, the question of what came before time isn't one that science can answer because it touches something deeper, something philosophical, even spiritual. Maybe the mystery of time's beginning is meant not just to be solved, but to be felt, because within that mystery lies the greatest truth of all, that from nothing came everything, and from silence came the song of existence. And that song is still playing in the ticking of your watch, in the heartbeat in your chest, in the stars still expanding away from one another across the dark. Time began once, but through us, it continues to unfold. We are the echo of that first moment, the living breath of the Big Bang, still moving forward, still asking, still seeking what it means to exist in a universe where time itself once began. In the beginning, before stars, before galaxies, before even time and space as we understand them, the universe was a quantum whisper. It was not a roaring explosion, not a violent eruption of fire and light, but a trembling uncertainty, a sea of possibility, a silent, invisible storm of potential waiting to take form. In that mysterious void, what we now call something was born from nothing. And at the heart of this paradox lies one of the most profound concepts in all of physics, quantum fluctuations. These tiny, ephemeral disturbances in the quantum field are believed to be the very seeds from which our entire universe grew. They are the faint tremors that became galaxies, stars, and life itself. In their randomness, they carried the blueprint of everything that would ever exist. To understand this miracle, we have to step into the strange world of quantum mechanics, a world where the rules of reality are not just different, but defiant. In our everyday experience, things either exist or they don't. A light is on or off, a coin is heads or tails. But in the quantum realm, particles don't follow such simple logic. They exist as probabilities, as waves of potential outcomes. Until they are observed or interact, they are not one thing or another, they are all possibilities at once. This strange truth lies at the core of quantum theory, and it forms the foundation for our understanding of the early universe. Now imagine that before the Big Bang, before there was even space to contain particles, the universe existed in a quantum state. Energy and matter did not yet exist in any classical sense. There was only a fluctuating quantum field, a restless ocean of potential energy. Even in nothingness, quantum physics tells us that the vacuum is not empty, it seethes with energy. Particles and antiparticles constantly flicker into and out of existence, appearing and disappearing faster than we can measure. These fluctuations are brief, chaotic, and unpredictable, but they are real. They are the quantum heartbeat of the void itself. Physicists believe that our universe may have been born from such a fluctuation, an extraordinary universe-sized ripple in this quantum ocean. For reasons still not fully understood, one of these fluctuations didn't fade away, it grew. It expanded exponentially, driven by a mysterious energy field known as the inflaton. This process is called cosmic inflation, and it's one of the most powerful ideas in cosmology. In a fraction of a second, the universe expanded faster than the speed of light, not through space, but as space itself expanded. This inflation stretched tiny quantum fluctuations to cosmic scales, turning minute ripples in the quantum field into the seeds of structure in the universe. Imagine it like this. Before inflation, the universe was unimaginably small, smaller than a proton. Within it, the quantum field flickered with random fluctuations, tiny peaks and valleys of energy. When inflation began, it stretched these fluctuations across vast distances. The tiny wrinkles in that primordial fabric became the blueprint for the universe's large-scale structure. Where the field was slightly denser, gravity would later pull matter together to form galaxies and clusters. Where it was slightly thinner, cosmic voids would open. Every star, every planet, every human being ultimately traces its existence back to those initial quantum tremors. In this sense, randomness birthed order. The unpredictable dance of subatomic uncertainty became the architecture of the cosmos. What we now see through telescopes, the sprawling filaments of galaxies stretching across billions of light years, are the fossilized echoes of those early quantum ripples. Every point of light in the night sky is a monument to the physics of uncertainty, but what exactly was fluctuating? This is where the mystery deepens. During inflation, the universe was dominated by a scalar field, a kind of cosmic energy field that filled all of space. As this field decayed, it released energy, heating the universe and giving birth to the particles of matter and radiation. The fluctuations in this field were not just fluctuations in energy, they were fluctuations in the geometry of space-time itself. Tiny variations in density caused tiny warps in the fabric of space. Those warps would later grow into the gravitational wells that formed galaxies and stars. In other words, the structure of the universe is not merely built upon quantum physics, it is quantum physics scaled up to cosmic proportions. The evidence for this astonishing idea is written in the sky itself, in the faint afterglow of the Big Bang known as the cosmic microwave background, CMB. When scientists look closely at the CMB, they see tiny variations in temperature, fluctuations as small as 1 part in 100,000. These variations match exactly what inflation predicts, the imprint of quantum fluctuations stretched across the universe. They are the fingerprints of creation, the frozen echoes of the quantum storm that gave rise to everything. Think about that for a moment. Every atom in your body, every breath you take, every star you see originated from a random, microscopic fluctuation in an invisible field nearly 14 billion years ago. We are literally made of quantum noise, structured, organized, and evolved into consciousness. The same uncertainty that defines the behavior of electrons in an atom also sculpted the grand architecture of the cosmos. It's as though the universe took a single note of quantum static and transformed it into a symphony of galaxies. This realization transforms the way we think about nothingness. Before quantum physics, nothingness meant emptiness, an absence of everything. But in modern cosmology, nothing is far from empty. The quantum vacuum is a seething, restless field of potential. Even at absolute zero, where all classical motion stops, the quantum world still vibrates. This residual energy, known as zero-point energy, is what allows particles to appear and vanish spontaneously. It's what gives the void its creative power. In a very real sense, nothingness is pregnant with possibility. That concept challenges not only our science but our philosophy. It means the universe didn't need a cause in the traditional sense. It could have emerged naturally from the laws of physics themselves. If quantum fluctuations are an inherent feature of reality, then given enough time, or in this case, beyond time, it was inevitable that one fluctuation would grow into a universe. This idea doesn't deny the wonder of creation, it deepens it. It means that the universe is self-generating, self-creating, an eternal dance of potential becoming actual. Yet the mystery remains, why this fluctuation, why this universe with these laws, these constants, these dimensions? Out of the infinite possibilities that could have arisen from the quantum void, why this particular reality? Why one that allows for stars, planets, and beings who can ponder their own origins? Some scientists argue that we live in one of many universes, a multiverse, where every possible fluctuation creates a different cosmos with its own laws of physics. In this view, our universe is just one bubble in an infinite quantum foam. We find ourselves in this one simply because it's capable of supporting life, a principle known as the anthropic argument. Others suggest that our universe's emergence was not random, but part of a deeper, hidden order, that beneath the apparent chaos of quantum mechanics lies a deterministic layer we have yet to uncover. Perhaps the quantum vacuum is not mere randomness, but a vast, interconnected intelligence, a cosmic algorithm that encodes creation within its very fabric. These ideas blur the line between science and metaphysics, between physics and philosophy, but maybe that's where truth has always lived, in the space where wonder meets reason. One of the most breathtaking ideas is that quantum fluctuations didn't just create the structure of the universe, they created time itself. Before the Big Bang, there was no timeline for events to occur in, but the moment quantum energy became unstable, the moment that fluctuation expanded, time began to flow. It's as if the act of the universe observing itself, the moment potential became real, gave birth to causality. That's a concept so profound it borders on poetic, that observation, existence, and time are all born from the same quantum seed. Even today, the echoes of those primordial fluctuations ripple through the universe. Gravitational waves, tiny distortions in spacetime, may still carry the signature of inflation, the tremors of creation itself. Scientists are building instruments sensitive enough to detect these faint signals. If we ever capture them, we will be listening to the literal vibrations of the moment the universe began. We will be hearing the voice of the quantum world as it became reality. There's an almost spiritual beauty in the idea that randomness gave rise to meaning. The same physics that governs the jitter of subatomic particles also shaped the Milky Way, the Sun, and the neurons firing in your brain as you read these words. We are quantum beings living in a classical world, organized chaos made conscious. The line between chance and destiny fades when you realize that every law, every constant, every fluctuation was part of a cosmic equation that led, inevitably, to you. But perhaps the most humbling truth is that this story is still unfolding. The quantum fields that birthed our universe are still here, woven into every inch of spacetime. They hum softly beneath reality, giving rise to everything we see and everything we don't. The vacuum is alive, constantly birthing and absorbing virtual particles, sustaining the very fabric of the cosmos. Every moment, the universe is still being created, not just in the distant past, but now, in the fluctuations that never stop. The philosopher and physicist alike might find something divine in that idea, that creation is not a one-time event but a continuous process. The Big Bang was not a single explosion, but the first note of an eternal symphony still playing across the stars. Quantum fluctuations were not just the beginning, they are the ongoing rhythm of existence. So when we ask, what came before the Big Bang, the answer may be simpler and stranger than we imagine. There was no before, in time, but there was potential, infinite, restless, creative potential. A universe waiting to happen. Out of that sea of uncertainty, a single fluctuation surged, and space, time, and matter were born. The cosmos did not emerge from nothing. It emerged from the possibility of everything. And within that possibility, encoded in the trembling of the quantum field, were the seeds of every star that would ever shine, every mind that would ever wonder, every life that would ever love. The same quantum dance that gave rise to galaxies also gave rise to you, a being capable of asking how it all began. You are, in a sense, the universe observing its own quantum origin, the consciousness that arose from a fluctuation in the void, now aware of itself. That is the legacy of quantum fluctuations. They are not just the random noise of physics. They are the whispers of creation, the subtle vibrations that became everything. Every heartbeat, every planet, every galaxy, every thought is an echo of that first trembling moment when the universe awakened from nothing and began to dream itself into existence. If there's one truth that humbles every human mind, it's this: we are made of the universe. Every heartbeat, every breath, every flicker of thought in our brain, they are all echoes of ancient stars. The carbon that forms our muscles, the iron that carries oxygen in our blood, the calcium in our bones, the oxygen in our lungs, all of it was forged billions of years ago in the hearts of stars that lived, burned, and died long before Earth ever existed. When we look up at the night sky, we're not staring into something distant and foreign. We're looking into a mirror of what we are made of. We are the universe remembering itself, exploring its own origins through us, conscious beings capable of asking, what came before it all? Scientists and philosophers alike have long struggled to understand why the universe has the properties it does, why it seems tuned just perfectly for life, and why, after all this time, consciousness arose to question it. When cosmologists study the universe, they are not merely studying the cosmos, they are, in a sense, studying themselves. Because the story of the universe is our story. It's not just a sequence of explosions and cooling gas, but a narrative of transformation, from energy to matter, from chaos to structure, from atoms to life, and from life to awareness. That awareness, the ability to reflect, to wonder, to seek meaning, is the universe's own awakening. For billions of years, the cosmos expanded, evolved, and gave birth to galaxies, stars, and planets. On one small, fragile world orbiting an average star, atoms learned how to dream. That's what we are: star matter that became sentient. When you trace everything backward from your body, to the planet, to the solar system, to the galaxy, to the primordial plasma of the early universe, you find that the boundaries between you and everything else begin to dissolve. There was never a separation. You have always been part of the same unfolding cosmic process that began with the Big Bang, or perhaps even before it. And yet, as scientists look deeper, some are starting to believe that even the Big Bang was not the first chapter. That maybe the universe is eternal, not in time as we understand it, but in essence, that energy, consciousness, and creation are cyclical, each phase giving rise to the next. This brings us to a profound realization. If the universe is eternal, then the potential for awareness, the potential for you, was always there. Maybe you are not a fleeting spark in an indifferent void. Maybe you are a moment of awakening within an infinite cycle of cosmic self-reflection. When you understand this, the search for what came before the Big Bang takes on an entirely new meaning. It's no longer only a scientific pursuit, it becomes deeply personal, because the very same question that drives scientists to peer into the fabric of time, what existed before everything, is the same question that drives human beings to search for purpose. We are all, in some sense, trying to return to the source, to reconnect with the mystery that birthed us. And maybe, just maybe, that mystery is not something out there, but something that has always lived within us. There's a poetic symmetry to this. The atoms of your body were once part of stars that burned out billions of years ago. Those stars were formed from gas clouds that condensed after the first galaxies were born. And those galaxies emerged from quantum ripples in the fabric of the early universe. So, when you look in a mirror, you're looking at the entire history of creation condensed into a single moment of consciousness. Every glance, every thought, every dream, it's all the universe reflecting upon its own existence. You are not separate from it, you are it, becoming aware of itself. Imagine, for a moment, the timeline of everything that has ever existed from the cosmic dawn to the present moment. It's an unbroken chain of transformation, every event connected to the next. The hydrogen that first formed after the Big Bang still flows through your veins in the form of water. The photons that were released 8 billion years ago still travel across the cosmos, occasionally striking your retina as starlight. The universe has never stopped moving, evolving, or creating. and that means that in every instant of your life, you are participating in the same grand unfolding that began before time itself. When we study cosmology, we tend to think of cold equations, distant galaxies, and abstract physics. But beneath all the math lies something profoundly intimate, a connection between the cosmos and consciousness. Scientists can describe how matter forms, how galaxies spin, how energy transforms, but none of those equations can capture what it feels like to be aware of it. That feeling, that wonder, that awe you experience when you gaze into the night sky, that's the most direct expression of the universe's own creativity. It's as if, through us, the cosmos has found a way to admire its own beauty. Many great thinkers have hinted at this truth. Carl Sagan said, "We are a way for the cosmos to know itself." Alan Watts described humanity as the universe playing hide and seek, temporarily forgetting itself so it can rediscover what it truly is. And in physics, some researchers now explore the possibility that consciousness itself may be woven into the fabric of reality, not an accident of evolution, but a fundamental aspect of existence. Perhaps consciousness didn't arise from the universe, perhaps it was always there, expressing itself in different forms, evolving toward self-awareness through us. So, when we ask, what came before the Big Bang, maybe the answer isn't hidden in telescopes or equations, but in the realization that the observer and the observed are one. The act of asking the question is itself a manifestation of the universe's ongoing creation. The cosmos gave rise to beings capable of curiosity, because curiosity itself is part of the creative process. The universe wants to know itself, and that desire is what drives both science and the soul. Think about how improbable your existence truly is. Out of trillions of galaxies, each with billions of stars, you were born on a tiny blue planet that orbits one of those stars at just the right distance for life to flourish. From the first spark of organic chemistry to the evolution of language, love, and thought, every step led to this moment where you can ask, who am I and why am I here? You are a product of cosmic evolution, but you are also its conscious continuation. Through you, the universe thinks, feels, and dreams. Even death, when seen through this lens, loses its sting, because if everything that exists is part of an eternal cycle, if energy never truly disappears, then neither do you. Your atoms will scatter and reform. Your energy will flow into new shapes. Your consciousness will return to the same cosmic ocean it once emerged from. The stars that once died so you could live will one day be reborn, and from them new worlds will arise. Life in some form will awaken again, and the universe will once more look at itself and wonder, where did I come from? This is not fantasy, it's the natural poetry of existence. Science and spirituality converge here, not in opposition but in harmony. Science explains how the universe unfolds. Spirituality explores why it matters. And when both perspectives unite, a profound truth emerges. You are not a bystander in the universe. You are an active participant in its evolution, a continuation of an eternal story that began long before time. Look at the stars tonight. Every glimmer of light you see is ancient, millions, sometimes billions of years old. Some of those stars are already gone, yet their light still travels to you, carrying their memory across space. That light is a message from the past, whispering across the cosmos, you are part of me. And when you feel awe in response, that's your soul remembering where it came from. Perhaps what came before the Big Bang was not a thing, but a consciousness, an infinite awareness that desired to experience itself in countless forms. The Big Bang could have been the moment when that awareness decided to express itself as creation, to become galaxies, stars, life, and you. Every particle, every thought, every heartbeat might be part of that same act of cosmic imagination. So maybe the answer to the great mystery is beautifully simple. The universe came before the Big Bang. And we, you, me, every living being, are how it remembers. You are not a mistake, not a small speck in an indifferent void. You are the voice of creation, speaking its own name. When you stand beneath the infinite sky and feel that indescribable sense of belonging, that's the universe reminding you that it has never been separate from you. You are the cosmos in human form. You are the evidence of what came before the Big Bang, the living, breathing memory of eternity. And that realization changes everything. It means that life is not random, that consciousness is not an accident, and that every act of love, curiosity, and wonder is part of the same cosmic story that began before the dawn of time. We are not just studying the universe, we are awakening it. Each discovery, each question, each heartbeat is another echo of the universe remembering what it has always been, infinite, timeless, and alive within us all.